Now, ladies and gentlemen, I believe this is where we left off on the last slide, or on the last video. We just determined that the top had to be equal to 0. Now, I'm not going to even attempt to solve this with my hand. It's messy. So what I would do is I would encourage you to graph this using x's, not t's, on your graphing calculator. Use the 0 function to find out where the graph crosses the x-axis. And when you do that, between 0 and pi, you get a value of about 2.798386. That, ladies and gentlemen, is the point of inflection. Now, that's the t value. That's not actually the x and y. To get the x and y, we take this t value and we plug it in here. T squared minus 5 would be 2.831 approximately. And 2 times sine of t would work out to be about 0.673. And that would be the end of that problem. Now, continuing on with our look at calculus, arc length. Now, the formula we have here for arc length is a little different from what you're used to seeing. We had one that was the integral, and it was radical 1 plus a derivative squared, and there was all kinds of stuff that you had to do. When you're dealing with parametrics, though, it's actually a lot easier. You just take the derivative of the y term squared, the derivative of the x term squared, square root of that, which, by the way, is essentially the Pythagorean theorem, and then we take the integral from the beginning to the ending point according to the interval given. So our job is to find the length of this shape. This shape is called an asteroid. Don't know if it looks like one or not, but that's what it's called. And the x formula is cosine cubed t, the y sine cubed t, and we're going from 0 to 2 pi. So we'll start with the derivative of the x term squared. Well, the derivative of cosine cubed t would be 3 cosine squared t. Bring your 3 out front, subtract 1. But then by the chain rule, the derivative of cosine is negative sine. And if we take that and square it, we get 9 cosine to the 4th sine squared t. Notice the negative is gone because of the square. Then we'll calculate the derivative of the y. That's going to be 3 sine squared. Again, 3 out front, subtract 1 on the exponent. The derivative of the inside would be cosine. Square that, and we have this. Now, these two things are what will go inside the radical. So we take the integral from 0 to pi over 2. Now, I'm going 0 to pi over 2 because, let me back up. That would be this part right here. Now, this is perfectly symmetric. So whatever I get for this, if I multiply it by 4, I'll have the whole shape. So 0 to pi over 2 times 4 of this. Now, you, of course, most people will go straight to your calculator and punch this in and get an answer, but we can solve it. Notice there is a common denominator of 9 cosine squared sine squared, so I can factor that out, leaving me with cosine squared plus sine squared, which we all know from pre-cal, that is an identity, that's equal to 1, so it's gone. And now I'm left with perfect squares here, so I can take the square root of each. And I have 3 cosine sine. Now, at this point, I would do a u substitution problem, or I could pull the 3 out first and then do u substitution. If I let u equal sine, du would be cosine, and that's how I get this, because the integral of u would be u squared over 2, so sine squared over 2. Again, if you're not following this, I can work it out by hand if you want, or you can remember to just go here, punch it into your calculator, and go to the very end and come up with the answer. But that's how I got this. I'll let u equal sine, did u substitution. Now the 2 and the 12 will simplify, and you can plug in your pi over 2 and your 0. And when all is said and done, you get 6, which, as I said, was what you would have gotten if you had done all this in your calculator to begin with. A cycloid. A cycloid is a special shape formed by taking a wheel and putting a dot on the wheel. Imagine that this dot has some ink in it. And as you roll that wheel, that dot is going up and down, but at the same time, it's also moving left and right. And if the ink is being left behind, the shape that's left behind is called a cycloid, and you'll see what that looks like on the next slide. Our job is to find the length of this cycloid. Looks like this. X equals a times t sine minus t, y equals a times 1 minus cosine t. Again, this is going to be a generic answer based on whatever a would be, but at least it gives us a formula for the future if we want to use it. So again, we'll start out with the x formula. Now, a is just a constant, so I'm not going to worry about the a. I'm going to look at the derivative of t minus sine t. That derivative would be 1 minus cosine t. Then I just leave the a where it is, and then, of course, we do have to square it, so squared. Now, to square that out, I'm going to have to do the FOIL method for 1 minus cosine t. That's how I get this part right here. And then, of course, a squared is a squared. Alright, do the same thing for y. What is the derivative of 1 minus cosine t? Well, that would just be sine t. And then there's the a. Square that. We have a squared sine squared t. Now let's take all that, put it inside of our radical. We are going from 0 to 2 pi. And now we've got to do something with all this mess. So I'll start out. I'll factor the a squared out here because you see there's an a squared, there's an a squared. So I factor out the common factor. And then I can put all the trig stuff together into this. Now notice again, sine squared plus cosine squared. Now, unless you're Katie Miller or John Compton, I don't think you're going to get to work this one out on your calculator because of the a. Okay? So I can put those things together. Cosine squared and sine squared is 1. 1 plus 1 is 2. Okay? Now we have this. The a, I can pull out front now. It is, I can take the square root of the a, or a squared, and I can pull it out here. Now at this point, you'd probably just use your calculator if you wanted to. It's whatever you want to do. I did use my calculator to get the integral from 0 to 2 pi of this. It does turn out to be 8. So the final answer is 8a. So I guess you probably could have, at this point, if you wanted to pull the a out, the a squared out, you could have then used your calculator here and wouldn't have had to do the next couple steps. And that, ladies and gentlemen, is all of 10.1. Stay tuned tomorrow for 10.2.